All right, welcome everybody. Let's do this. This is lesson 29 and it's a review of continuity and differentiability, okay? So before we start, quick shout outs to Alexis, Kiefer, and Rashat from staying from 2:30 today, from 2:30 to 3:15 for AP Calc Prep. So big shout out to you guys. Where was everybody else? I don't get it. Did you not get the memo or something? But okay. All right, so how are we? Oh, yo, shout out to Sydney Prias as well. I'm not gonna say why she's getting a shout out. You could ask her why she gets the shout out for today for what she did. But okay, um, let's do this. So first part, it says give a precise definition for what it means for a function to be continuous at x equals a. Okay, so that idea of continuous, what does it mean? Let's take a look. So let's say we have, let's zoom in a little bit. It says a function is continuous at a point if and only if the limit is equal to what you plug in. So for example, let's take a look at this function over here. Notice that this function right now is continuous at the point A because at A, the limit exists. And what is the limit of this? What is the limit as f of x as x approaches a? What's the limit of this? It's L. And notice when you plug in a, what do you get? You also get L. So you have L equals L. So whenever the limit equals the actual point you plug in, that is the precise definition of continuity or being continuous. Okay, so let's look at the next part. Here it's saying, imagine if we have this piecewise function. Let me zoom out a little bit. Okay, that's good. So let me do this, sorry. Camera angle. Okay, that's a little better. Okay, so let's say if we have this function, the question is the function continuous at x equals 5? And notice you don't have a picture. Like, we don't know what the graph looks like yet. But one thing that has to be true is when the limit exists, right? Notice that the limit from the left equals the limit from the right, okay? And that's what we need to check over here. So visually, what is going on over here? Notice that at x equals, oh, this is a typo. This should say -5, I'm sorry. It's saying at -5, right? Is this function continuous? So notice, you know at -5 from here, what is happening left of, oh, I'm sorry, this camera angle is really bad. What is happening left of -5? Which function is being used? It's going to be this function over here, okay? Because here you have x is less than or equal to -5. So everything less than or equal to -5, it's going to be the function over here of 9 minus x squared. So 9 minus x squared lives to the left of -5. What lives to the right of -5? That would be every x value greater than -5, and that's -10 plus x, okay? So the idea is we want to see if the limit exists, right? Does the limit from the left equal the limit from the right, okay? So here, let's take a look at 9 minus x squared. If you plug in -5 in here, so let's do that first. Let me put this over here. Let me get this. So if you have 9 minus x squared, right? And you plug in -5, so you have 9 minus a -5 squared, so that's 9 minus 25. This equals -6. Oh my God, I'm sorry, class. This equals -16. Okay, so notice that when x is -5, this graph over here is at -16 over here. And the question, is it open or closed? You know it's closed because you have this over here. So you know, you don't know what's happening in this graph. Just imagine that it's just something's happening and then it hits over here. The idea is, does this graph over here, does it hit also at -16? Because if it does, then we have continuity. If it doesn't, then we're not going to have continuity. So here, notice from the left, it's going to negative 16. And what happens to the right? Well, let's plug in negative 5. So if you have negative 10 minus a negative 5, this becomes negative 10 plus 5, and this is negative 5. So notice from the right side, it is going to, there should be a plus here, I'm sorry. So this should be a negative 10 minus 5, so this should be negative 15, very sorry. So notice that the graph goes to here at this point, and the question is it open or closed? It has to be open, but the idea is this function is not continuous, because based on the definition, when you plug, the limit for 1 doesn't exist. Yeah, the limit doesn't exist, so the function is not continuous, okay? So here, not continuous. What about this one over here? Let's try the next problem. So here, it says determine whether this function is continuous at, let me zoom out a little bit. Oh, sorry. Okay, is this function continuous at x equals 4? So let's see. What's happening in this picture? Notice that visually what's happening. If you're at 4 over here, okay, so let's say if we draw some line over here, what's happening to the right at 4? Okay, which function, which one of these parts of the piecewise function lives to the right of 4? It's going to be this one over here. So 8 minus 3x lives to the right of 4, because when x is greater than 4, you're using this function. Here, which lives to the left of 4, it's going to be this 9 minus 2x squared. The idea is, do they meet at the same point somewhere? Okay, so let's take a look. Here, let's plug in 4 to each one of the equations. So if I have 9 minus x squared, and I'm sorry, 9 minus 2x squared, what happens when you plug in 4? So it's going to be 9 minus 2 times 4 squared. That's 9 minus 2 times 16. If you did 2 times 4, I'm going to be heartbroken, right? Because you have to square it for first. So then you have 9 minus 32. And what is 9 minus 32? 9 minus 32 is negative 21. Okay? So you know from the left side of this graph, it's going all the way down to 5, 10, 15, 20. It's somewhere here. Okay? And the idea is this open or closed, this picture over here? Is it open or closed? Notice from the left, it's closed because we have this equal sign as well. So this is closed. And, you know, whatever happens here. Now let's see, does it come from the right? Does it go to the same point? If I have 8 minus 3x, oh, I'm sorry, that should be a negative 8. Negative 8 minus 3x, so this is negative 8 minus 3 times 4, that's negative 8 minus 12, that's negative 20. Ooh, it was close. So you see how negative 21 doesn't equal negative 20? Negative 21 does not equal negative 20. It was close, but you know that this piecewise function, so we can say this piecewise function is not continuous at x equals 4. Okay? It's continuous everywhere else. Like here it's continuous, 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 not, and then it's still continuous from here, right? Because the limits exist and it's equal to the point. Okay, great. So that's the idea of continuity. Let's look at the next part over here. Here it's saying determine whether the function is differentiable, continuous, both or neither at the value where the rule for the function changes. So here we're okay with this idea of continuity. The question we have next is what does this mean to be differentiable? Oh, sorry. So we're okay with this idea of continuity. What does it mean to be differentiable? So the idea for differentiability is, we want the slope from the left to equal the slope from the right. So we'll get to that first. So whenever you have some problem like this, the first idea you want to check is, so move number one. Move number one, check for continuity. Okay? So let's see. Is this function continuous at x equals 2? All right? What I want you to do is try and do this by yourself without me. Okay? So let's see. We want to see if the limit as x approaches 2 from the left equals the limit as x approaches 2 from the right. So I didn't show that in the previous example, but I'm just being a little fancy here. As limit as x approaches 2 from the left will be which one of these? It'll be this one here, because this is saying x is less than 2. So if I have like 0, 1, 2, everything to the left of 2 will be using this 14x plus 6. So now I just say 14 times 2 plus 6. Does that equal, question mark, 2 from the right will be 2 squared plus 8 times 2 plus 15. This is what, 28 plus 6. This is what, 4 plus 16 plus 15. So this is 34, and this is 4 plus, this is 35. So no, not continuous. And if it's not continuous, thus not differentiable. Okay? And then we're done. The idea is a function must be continuous for it to be differentiable. So the second a function is not continuous, it's not differentiable. So we don't need to check for differentiability because we know it's not continuous. Let's look at the next problem. Now let's see what happens if the function is continuous, which I think this example will be. But same idea, what I want you to do is check if this function is continuous at x equals 20. So for here, the limit as x approaches 20 from the left has to equal the limit as x approaches 20 from the right. So here, let's see, 20 from the left would be this function, it would be this function over here. So we have 3 times 20 plus 17 has to equal 20 squared minus 15 times 20 minus 23. Okay, let's see if this works. 3 times 20 is 60 plus 17. This is 400 minus 300 minus 23. This becomes 77 equals 100 minus 23. So 77 equals 77. So check. We know that this function is, so the function is continuous. Okay? And one other tiny thing to check. For example, if we had this, for example, if we look over here, like, my bad. Right now, when you plug in, like, what is f of 20? Notice when you plug in 20, which equation are you going to plug it into, the top or the bottom? You're going to plug it into this one because you have the equal sign. So if you hypothetically had this right now, the function would not be continuous because you don't have the value. You have to make sure you have the equal sign here. So here, you know that the function is continuous. Now the big picture idea is, question, is the function differentiable? Okay. Right. So what did we talk about over here? The idea is the slope from the left equal to the slope from the right? And when you think about slopes, you have to think about derivatives. What this is saying is that if you have this function over here, what is the slope of this function at 20? Well, what do you need to do? You need to take the derivative of this function and plug in 20 to get the slope. We need to take the derivative of this function and plug in 20 to get the slope. And we want to see if the slopes match at 20. So the idea for differentiability is, what is the derivative of the top? You see, so if I have the limit as x approaches 20 of f prime of x. Well, as you approach it from the left, right, you're using which function? You're using this one. Well, what's the derivative of this function of 3x plus 17? It's just 3. Okay? Now, is it equal to the limit as x approaches 20 from the right of f prime of x? You see, now we need to check the derivative of the top and plug in 20. So here, what's the derivative of the top? It's 2x minus 15. But when we plug in 20, does 3 equal 2 times 20 minus 15? Question mark. And this is a no. This is 40 minus 15. 3 does not equal 35. Thus, the function is not differentiable. Thus, the function is not differentiable. Okay? Okay, so visually, what does this mean? It's saying that, like, let's say if I have something like this, if the slope here is 3, I don't know, maybe it looks something like this. And then for this function, it could look like that. And notice that because you have this kind of visual here, the function will not be differentiable. Okay, why don't we try one more, and then we're done for today. Try this one. Is the function differentiable, continuous, both or neither? For this one here. Okay, so let's see. Continuous, question mark? So let's check for continuity. So the limit as x approaches 5 from the left for f of x has to equal the limit as x approaches 5 from the right of f of x. Okay? So then what happens here? So which one of these functions is coming from the left? It would have to be this function here, because it's saying x is less than or equal to 5. So if I plug in 5 for the bottom, here negative 8 times 5 minus 5, does that equal to 5 squared minus 18 times 5 plus 20? So here, minus 8 times 5 is negative 40, minus 5, does that equal 25 minus, what's 18 times 5? 90 plus 20. So this is negative 45, does it equal, let's see, 25 minus 90 is negative 75, no, negative 65. So it's negative 65 plus 20. Negative 45 equals negative 45. Okay, so this looks good. And do we have the equal sign here? Yes. So the function is continuous at x equals 5. Okay? Now we need to check differentiability. So differentiable, question mark. Well, what do we need to do? We need to check the slope from the left and from the right. So we need to take the derivative of the left and from the right. So here, the limit, and let me draw a line over here. The limit as x approaches 5 from the left of f prime of x, does that equal the limit as x approaches 5 from the right of f prime of x? So here, we need to find the derivative. What is the derivative of the top? That's just 2x minus 18. What's the derivative of the bottom? It's just negative 8. So if we plug in negative 5 from the left, so this is just negative 8. Because you can't plug in 5, there's no variable, so it just becomes negative 8. And here this becomes 2 times 5 minus 18, this is negative 8 equals 10 minus 18, negative 8 equals negative 8. Thus, the function is differentiable at x equals 5. So it's continuous and differentiable. Happy face. Okay, we are done for today. What I'll give for you to do, there is a delta math, which is not too bad. This topic for today really wasn't too bad. For this question over here, I'm pretty tired. I don't feel like explaining this anymore. I'll show this one in class tomorrow. And if you can, is there other questions? Oh yeah, this we'll do tomorrow. And this, if you want, this is review of L'Hopital's rule. These two questions are AP calculus questions. What you could do is try and do these questions before coming to class. So yeah. All right, great job. Proud of you. Enjoy.